Welcome to Study Loop.
Welcome to question number 23.42, chapter 23, electric potential. Here we have given that there is a plastic sheet of charge. So this is a very large sheet. This has sigma equals to minus 6 into 10 to the minus 9 coulomb per meter square, which is minus 6 nano coulomb per meter square. So this is the surface charge density on this sheet of charge. So the first question is where is the electric field? So electric field due to the minus surface charge density should be towards the sheet of the charge itself. And we know that the electric field due to sigma charge density by a infinite plane sheet of charge is equal to sigma over 2 epsilon naught n cap. N cap is the perpendicular to the plane of sheet. N cap is perpendicular to plane of sheet. So looking at this sigma, we have this negative here. So that means the direction of the electric field changes towards the sheet of charge. All right. So we have this formula again. So these are two formulas. Delta V is equals to ED. That means the potential difference between this point and the point from the surface. So using these two formula, we can find out the value of the D here. But coming to the A part, so the question says as you move away from the sheet of the along of the line perpendicular to it, does the potential increase or decrease? So definitely. So we have negative charge density here. So if we have positive charge, any positive charge, so the potential decreases because your E is having minus sigma. So your potential decreases as you move towards the surface. But the magnitude of the potential increases because the sign is opposite due to the this sigma charge here. The question says, does your answer depend on the where you choose your reference point for your potential? Yes, it does. So if we take some point here and if we take another point here, the potential difference between these two points and the potential difference between these 2 points is different because the potential difference dependent on the d. So yes, the potential difference between two any points is dependent on the reference. So going to the calculations now for using this information. So the question is what would be the distance to increase the potential by 1 volt? So we have delta V equals to 1 volt. So we can find out the D here. So we have 1 volt equals to ED. Your E is equals to sigma by 2 epsilon naught. So this becomes 2 epsilon naught sigma d equals to 1. So d equals to 2 epsilon naught over sigma. So put in the values here. So we have 2 into 8.85 into 10 to the power minus 12 over 6.00 10 to the power minus 9. So we have the value here equals to 0.00295 meter. So using calculator I have find out the value here. So distance is this one. So at each d, the potential delta V is equals to 1 volt. So your potential on this plane is equals to, let's say we have V prime. So this is your equipotential plane. And the distance from the surface of the sheet of the charge, which is d, which is equal to this one. So we have another sheet, or you can say that plane, which has, let's say this is V double prime. This is another equipotential surface. These surfaces have the same geometry as like the your sheet of the charge. So let me make more perfect diagram. So we have sheet of charge here, your equipotential surfaces are these ones, which are the plane. This is first plane, let's say, and let me make another plane. The distance between each plane is d. So the potential difference between these two is equals to 1 volt. Potential difference between these two is 1 volt. Your distance can be arbitrary, but equipotential surfaces are parallel planes to sheet of charge. So similar kind of the planes you should be having here if you want to draw more equipotential planes here. And as the d increases. All right. So we have done everything what the question is. So that's your answer for the this question. Thank you very much.